Hi everyone, we are group 3 and our topic is over climate warming and wildfires, and our group consists of myself, Shannon McClung, Emily Lynch, Noah Masters, Kayla McCoy, and Amanda Miller. So to begin, the article that we were assigned for our topic was called Warming and Earlier Spring Increase Western U.S. Forest Wildfire Activity, and pictured on the slide is our citation for the article, as well as a little infographic showing how these rising temperatures and climate change is affecting our wildfires, specifically in the western United States. So to start with some background information, wildfires are uncontrolled fires that cause mass destruction, and none of us want that, but yet they are on a recent increase, specifically in the western United States. But there's a lack of research on the extent of this increase, as well as the relation to climate change and climate warming. That is why this study has been conducted, to prove that there is an association between the spring wildfires and the earlier snowmelt due to climate warming.
There are two main competing causes for the current trend in wildfire activity. Those are land use and climate. Land use is talking about the history dating back to the late 19th century and early 20th century, and how people began to clear parts of the forest with logging in order to make a place for their homes. This led to them creating space for farms to raise livestock and using fuel to run things in their homes and many other things. The need for fire suppression grew, which in turn did not allow forests to naturally start over. Climate is an alternative explanation for the trend in increasing wildfires. This is basically stating that increasing changes in moisture and/or increasing changes in drought and warmer temperatures is the cause. The risk of these wildfires is higher in areas going through a drought in the summer season. Forest management can also be a potential helpful act in regards to people helping build ecosystems back up and reducing hazards. However, it may not be enough in the long run. While climate and management are used as two separate competing explanations for increasing wildfires, they may also play into one another, meaning that past land use could have increased the sensitivity of forests to climate changes, like extreme droughts, to things like overabundant fuels in the forest. According to the article, however, it is believed that climate may still be the main factor of wildfires.
My name is Noah Masters, and I will be discussing the methods from this article. The researchers began by looking at the hydroclimatic data in relation to the western United States and forest fires. This hydroclimatic data measures the average stream flow in the United States and its territories. A visual representation of what this looks like can be seen on the right. Red indicates a low stream flow, and green indicates a higher stream flow. The researchers then took a sample size of 1,166 large forest fires only greater than 400 hectares. 1 hectare is equal to 100 acres. Also, these samples were only taken from 1970 to 2003, 61% of which were in the western United States, and 80% of them were above 1,370 meters in elevation. After taking the hydroclimatic data and sample size, the researchers then wanted to look if other land surface variables indicated higher forest fires in the western United States. Because of this, they looked into land elevation. Lastly, researchers wanted to see if snowmelt was another climate factor that resulted in higher forest fires in the western United States. Snowmelt is simply the melting of snow turning into water from the change of seasons from winter to spring. What the researchers did was measure the percent difference in moisture deficit from early versus late snowmelt years. The researchers compared it to what regular temperatures in the western United States looks like here on the left, and then how the early coming or late coming of the snowmelt years changes vulnerability in the forest areas seen here on the right in the western United States.
So for the results, the article showed that there overall was an increase in forest wildfire activity. The wildfire frequency in the 1980s was 4 times what it was before, and the total area burned was over 6.5 times what it was before. In the figure to the right, figure A, it shows that when there's a higher temperature, the black line, there's also an increase in wildfires. The numbers they found to go with that were that the wildfire season increased by 78 days and an individual wildfire increased by 15 days. The next result that was found was Fire activity and its relation to timing of the spring snowmelt. So an earlier snowmelt is going to mean an increase in wildfire frequency. This is because there's going to be a longer dry season, which gives fires more time to occur. 72% of area burned in earlier snowmelt years as opposed to in years that snowmelt was later. And another explanation for this happening is that when there's an increase in temperature, as I said, there's going to be a longer summer drought, more time for fires, and there's also going to be more flammability of alive and dead fuels. You can see this in graph B to the right. In earlier snow seasons, there are far more fires. The last result found was spatial variability in fire response to early spring. This is dependent on the spatial distribution of forest area and the local water that is around it to balance out the forest area. The figure shown represents the difference of cumulative moisture deficit in early versus late snowmelt years. So places that already had low elevation already had very long droughts, so they were used to it, but places that didn't and were having longer droughts had more vulnerability because they had a larger difference in cumulative moisture.
Statistical associations between wildfires and hydroclimate were found in this study. This indicates that most wildfires are caused by climate change. A large factor in this is that reduced winter precipitation and early snow melting in the spring had a large influence on wildfires. As well as climate change being a main cause, land use also comes into play as a factor in certain forest types such as ponderosa pine forests and mixed conifer forests. Many forests did not involve the factor of land use, and this indicates that ecological restoration and fuel management is not enough to reduce these fires. The Northern Rockies and Northern California, along with the Southern Rockies and Southern California, are the two regions most affected by wildfires today. The findings of this study are important because it's essential to understand what causes wildfires and how they may affect future areas where people live. This can also be a call to action for many to do more research on these findings and help discover ways to reduce the spread of wildfires in the future. It also helps us maintain our resources, protect people, and helps to reduce high amounts of carbon dioxide in the atmosphere. Regional and global implications of this study's findings are increased frequency of wildfires will change forest composition and density. Biomass burning will result in mass carbon release causing high amounts of carbon dioxide in the atmosphere. And increasing wildfires pose a threat to human communities and ecosystems. This concludes our presentation on climate warming and wildfires. Thank you for watching.